In this video, we're going to talk about how to raise complex numbers in the trig or polar form to a power. For pronouncing this theorem, you could either say de Moivre or de Moivre. So here's what the theorem looks like. If you have a complex number in that trig or polar form, whichever terminology they're using, we should have an r value up front and then cosine of theta and I sine of theta inside of parentheses. So the theorem applies to when we take one of the numbers in that form and raise it to a power. So it could be the second power, third power, fourth power, whatever. So n is going to represent the exponent in this case. So if you look over here, this is telling us what to do with that exponent. We take the r value up front and we raise it to that power. So just apply the exponent to the first number normally. For the stuff inside of parentheses, though, you take whatever that exponent is and you multiply it by your angle. So if you had the third power, whether this is in degree or radian mode, does not matter. You would just take whatever the angle is and multiply it by 3. And then it should end up being the same angle in both spots because these two values should have been the same. So when you multiply that number by n, it should still be the same angle for both of them. So I've written that out as a description in words as well. Basically, you need to take the r value and raise it to the n power, where n is the exponent. And you need to take your angles, which are the theta values, and multiply them by n. Now, some of your assignments will give you the complex number in the standard form. It'll be the a plus bi instead of this r cosine theta plus I sine of theta. When that happens, you'll have to change it to polar form first, which is something we did in a previous video, a couple videos ago. I showed you how to convert the numbers over. Then you would apply the exponent. And then again, sometimes the questions may ask you to change them back to standard form, in which case you would again want to refer to that earlier video for how to convert from your trig or polar form and change to standard form. So here's our first example. We're being asked to evaluate 2 times cosine of pi over 2 plus I sine of pi over 2. So remember that this value up front, that's my r, and then the angles, it should be the same angle both times. That angle, whatever it is our theta value. And in this case, n is the 4. So I'm just labeling what these numbers mean in relation to the formula. So if we're applying the formula that I gave you on the previous slide, it says to take r and raise it to the n power. So I would write 2 to the 4th power. And then inside of the parentheses, I'm going to have cosine, and we need to multiply this number times pi over 2. So 4 over 1 times pi over 2 would be 4 pi over 2. Now you really want to simplify that. I'm just trying to show you that I'm multiplying 4 times pi over 2, and I'll do the reducing as a separate step in a moment. And then the same thing for this other one. You should get the same value both times. It should never be different. So now I should have 4 times pi over 2 here as well. So that's how we apply the exponent to the complex number. Now we just want to simplify this a little bit. So you want to evaluate 2 to the 4th power. And like I said on this, we should be able to simplify 4 pi over 2. Let's instead call that 2 pi. And that angle should always be the same for both the cosine and the I times sine part. Now, if they had asked us to write the answer in trig or polar form, we would be done. This is our complex number in the trig or polar form. But they didn't. They asked us to express it in a plus bi form, which is standard form. So now I know what r is. I know what theta is. So from the earlier notes, I showed you guys that a is equal to r cosine of theta, and b is equal to r sine of theta. When you're changing the number to the other form, you're basically just distributing. You're doing 16 times cosine of 2 pi and 16 times I sine of 2 pi, and that's what's creating your a plus bi value. So the b right now, I'm just ignoring the I for a second because that's a separate value being multiplied by b. So in this case, we need to know that cosine of 2 pi is equal to 1. So 1 times 16 is 16. And sine of 2 pi is 0. So 0 times 16 is 0. So when I write a plus bi, if I'm plugging those numbers in, you end up with 16 plus 0i. Like I said, I just distributed 16 times this and 16 times this. But we don't need to write the 0i. 0 times anything cancels out. So you would just write the number 16 for your answer on this one. Here's another example where we're being asked to raise a complex number to a power. Now the tricky thing on this one is my complex number is in standard form. So I'm going to set up the conversion and rewrite this in polar form first. So here's my work for converting the standard form to trig or polar form. I did r equals the square root of a squared plus b squared, where a is 2 and b is 2. And 4 plus 4 is 8. Square root of 8 is 2 root 2. You don't have to do the plus or minus on this. We're only going to be working with the positive r value. The negative r value does that weird stuff about like flipping around the polar coordinate. It really doesn't have a meaning in the complex. It's a different concept completely. So for the theta value, you do tangent inverse of b over a. And then you might want to think of that as the number 1 instead. And then in your unit circle, don't forget there are 2 values. If you do this in your calculator, it's only going to show you one of the answers. So on the unit circle, you might want to look to see that there are 2 answers that are the same, and they should be pi away from each other. They're on opposite sides of the origin. What you do need to keep in mind is that we need to pick which one is right based on the original coordinate. If I told you to graph 2 plus 2y, that's a positive x value and a positive y value. It's going right and up. So I need to pick the angle that's in the first quadrant, the one that's going right and up. So that would be this one. So once you have your r and your theta value, at that point you can rewrite the complex number. So now I know that 2 plus 2i is the same as 2 root 2, and then cosine of pi over 4, because that's the theta value we chose, plus I sine of pi over 4. So all the work we've done so far, this is actually just reviewing something from an earlier video. This was how to convert the number from one form to the other. And that number is being raised to the third power. I have not touched the exponent yet. I've just rewritten the 2 plus 2i part into the other form. So now we're going to use the Moivre's theorem to raise the first value to the third power and then multiply the angle by 3. So 2 root 2 cubed, you might want to think of the 2 and the root 2 cubed as separate things. 2 cubed is 8, and root 2 cubed is 2 root 2. So 8 times 2 root 2 is 16 root 2. And then inside for the theta values for the cosine and sine part, I just need to evaluate pi over 4 times 3 over 1. So that's going to end up being 3 pi over 4. Just multiply theta by the exponent. And then there was no simplifying to do on that one in this case. So if they had asked for the answer in trig or polar form, we would be done. We have applied the exponent to both the r value and to the theta values. But this one asked us to express our answer in standard form again. So for this particular problem, I need to do that distributing process again, basically. So A is going to come from evaluating 16 root 2 times cosine of 3 pi over 4. And B is going to come from evaluating 16 root 2 times sine of 3 pi over 4. If you're looking at your unit circle, cosine of 3 pi over 4 is equal to negative root 2 over 2. And then if I continue evaluating this, well, I can take the 16 and cut it in half, so that'll be 8. And root 2 times root 2 is 2. So 8 times 2 is 16, but also don't forget about that negative there. So this should end up equaling negative 16. So again, I'm doing half of 16, and I'm doing root 2 times root 2 is 2, so 2 times 8 is 16. For the b value, evaluate the sine of 3 pi over 4 part. And on the unit circle, you should see that this is a positive root 2 over 2. So the cosine one was negative, the sine one is positive. So it'll be pretty similar computation-wise. Half of 16 is 8. And if I do the root 2 times root 2, that's 2. So 8 times 2 is 16. So for this one, I have a equals negative 16 and b equals positive 16, which means my answer would, in standard form, would be negative 16 plus 16i. That's our complex number. This one made us convert it both ways. We had to convert it to polar form and then convert it back to standard form. So just keep this in mind that the formula I've given you only works for polar form, and then pay attention to what form they want your answer in. So that's it for the notes. Thanks, guys.